Welcome to All This Math. This is Professor Parker, and today we are going to solve an equation, or I should say solve an exponential equation, right? That's one of the ways we describe this. We have 6 to the 3x power times 6 to the x plus 2 power is equal to 216 to the 3x power, right? Now, to many people, that looks real complicated, looks real difficult. It might even look downright scary to some people. But it only looks like that if you don't know how to do it. If you never sat in a math class and nobody ever taught you how to do it. If you sat in a math class and somebody taught you how to do a problem like this and taught you how to use the exponent rules and apply it to this type of situation that you see right here on this board, then it's not that scary. It's not that difficult. You know how to do it. All right. So if you have not ever been taught how to do this, or you got homework to do that looks like this, let me break it down for you so you'll know how to do it. All right. So we first start out taking account of what we have. 6 to the 3x power times 6 to the x plus 2 power is equal to 216 to the 3x power. All right, so we got that. Now, I can only really work with this if my bases are all the same. Right now, my bases are not all the same. 2 of them are the same. 6 is my base in this term. 6 is my base in this term. 216 is my base in this term right here, though. So I can only work with this if my bases are all the same. But lucky for me, I know something about the perfect cubes, meaning the numbers that you get when you do 1 times 1 times 1, 2 times 2 times 2. Those are the perfect cubes, or the numbers raised to the third power. 1 to the third power is 1. I know that. And these are pieces of information that you should memorize. So 1 to the third power equals 1. I know that 2 to the third power equals 8. I also know that 3 to the third power equals 27. 4 to the third power is 64. 5 to the third power is 125. And I know that 6 to the third power is 216. Don't I have a 216 right there? Isn't it equal to 6 to the third power? So I need an equation that has all 6's as my bases anyway. So I could rewrite this equation. I could replace the 216 with 6 to the third power. So watch what it looks like. It's going to look like this. 6 to the 3x power times 6 to the x plus 2 power is equal to 6 to the third power raised to the 3x power. Because that 3x was already the exponent. The 3x was already the exponent, right? But I changed the 216 to just 6 to the third power. So 216, 6 to the third power. The 3x was already the exponent, so that's outside the parentheses. So now I'm going to apply the exponent rules so I can set up an equation with just the exponents. I'm going to apply them exponent rules that you learned already, that you thought you were never going to have to use again, to create an equation using just the exponents. So when you multiply two terms and the bases are the same, what do you do with the exponents? You add them together, right? You don't multiply them, you don't divide them, you don't subtract them. When you're multiplying two terms, it don't matter if the base is a variable or a number. When you multiply two terms, you add the exponents. So that means that I can apply the exponent rules here. So that means that I should be able to do 3x plus x plus 2 is equal to, this is going to become 9x. Why is that going to become 9x? Because of what some textbooks call the power of a power rule. What I call it is the distributive exponent rule, right? Because you distribute this 3x to the 3, and it becomes 9x. So that's my new equation, all right? So see, it don't look complicated no more. It don't look, as difficult no more or as scary, because we took the exponents, 3x, x plus 2, and what will become 9x, and we created its own equation. And now we back to doing algebra 1 now. We need to combine like terms. That's a like term, and that's a like term. 3x and x is 4x plus 2 equals 9x. And I need to get my x's all on one side, right? So what I'm going to do is I'm going to do minus 4x on the left, boom. And I'm going to do minus 4x on the left. I bring the 2 down. 9 minus 4 is 5. So 9x minus 4x is 5x. Now I got one more step. Get rid of this 5. I do the opposite operation of multiplication because 5x means 5 times x. So I do the opposite operation of multiplication to get rid of the 5. Divide by 5. Divide by 5. And I got 2/5. And I'm going to write it the other way around. Instead of writing 2/5 equals x, I'm going to do it x equals 2/5. All right. But I'm not done, though. I always like to check my work, make sure that my answer is right. So let me check my work. All right. So basically, let me go back up here and say, okay, what's 3 times 2/5? 3 times 2/5. As a matter of fact, let me switch my marker up. Do my check. So if I'm going to check my work, let's check it right here. So I got 6 to the 3 times 2/5 is 6/5. I'm multiplying that by 2/5 plus 2. 2/5 plus 2, that's equal to 216 to the 3 times 2/5. Hold on one second. You good?
Yes, thank you.
Okay. Good luck. All right. Had to grab something from a student. All right, so let me break this down. Make sure that this is correct. So 6 to the 6/5, I'm gonna write that over again. And then 2/5 plus 2, I need common denominators. 2/5 plus 2, 2 is the same thing as 10/5. So that's gonna be 6 to the 2/5 plus 10/5 is 12/5. And that's equal to 216 to the 6/5, right? So we got 6/5, 12/5. Now, again, right? I should be able to do, wait, is this 3 times 2/5? 6/5. 6/5 plus 2. 3 times 6 to the 6. Oh, I forgot. No, I didn't. 6/5. 2/5 plus 2. 2/5 plus 10/5 is 12/5. How's that 18/5? Oh, okay. Yeah. Okay. I see what's going on. 6 to the, thought I did something wrong. I didn't. 6 to the 18/5 is equal to 216 to the 6/5, right? But remember, 216 is the same thing as 6 to the 3rd. So 6 to the 3rd to the 6/5 is going to be 6 to the 18/5. And the left side equals the right side, so it's a true statement. So that's proof that this is right. All right? I know I got a little messy, but I mean, this ain't Hollywood, This is how I really would be in the classroom. You're up at the board doing problems, getting your hands dirty, getting your work in. Somebody come knock on the door, you got to stop in the middle of your lesson, in the middle of the problem you're going over, go tend to that. Got to multitask, got to come back, finish working. Just because we're on YouTube, I mean, we being real. This is what really happens. This is math. This is what happens, right? So anyway, we looked at how to solve an exponential equation, right? We solve for x, but then we always go back. You should always go back and check your work to make sure that your work is correct. That way, you don't need the validation from somebody else, right? You don't need to wait for your teacher to tell you, yes, it's right or no, it's wrong. You can find that out on your own. You just go back to the original equation. You take your answer, substitute in wherever you see an x at, all right? Wherever you see an x at. 3 times 2/5, 6/5. 2/5 plus 2. Now, we got to know how to add and subtract fractions with unlike denominators. That's a fundamental skill that we got to have. If we don't know how to do that, we got to practice that. We got to know how to do that at any given moment because we never know when we're going to have to use that skill, right? So I need to know that 2/5 plus 2 is the same thing as 2/5 plus 10/5. I need to know that. I got to know that, right? And then if I know that, I know that that's equal to 12/5, right? And then over here, 216 to the 3x. Again, 3 times 2/5 is 6/5. And then I just, again, applying the exponent rules. When you multiply two terms that have the same base, we're going to add the exponents together. 6/5 and 12/5 is 18/5. But over here, and this is what kind of stumped me a little bit because I wasn't realizing, like, wait, my exponents are supposed to match up. That's 18/5, that's 6/5. I didn't realize that, oh, that's a 216. That's why I'm going to break the 216 down into 6 to the third power, just like I did right here. And then once I do that, then I'm going to apply another exponent rule, which is what I call the distributive exponent rule. And I'm going to multiply the exponent outside by the exponent inside. 3 times 6 to the 5th gives me 18/5. So now I got my 6 to the 18/5 on the left, and I got my 6 to the 18/5 on the right. You know what I'm saying? So now, that's proof that we did it right. All right? So please like the video, subscribe to the page, share the video, you know, tell some people about it. Tell some people about what we're doing over here, all this math. And as always, do remember that there's all this math all around you.